In this video, we're going to be looking at differentiating trigonometric, exponential, and logarithm functions. Now, for the additional mathematics course, 0606, the trig functions you need to be able to differentiate are sine, cos, and tan. Now, it's worth memorizing these, that the differential of sine x is cos x, the differential of cos x is minus sine x, and the differential of tan x is sec squared x. These are the basic differentials, obviously not using any of the rules, that you need to memorize. We can use this with the chain rule, the product, and the quotient rule. So let's say that we wanted to differentiate sine of 3x minus 4. Now, we're going to be using the chain rule, and the reason we're going to be using the chain rule is that it's a function of a function, right? The first function on the inside of the brackets is 3x minus 4, and the function on the outside is the sine. So if I think about the chain rule, I differentiate the outside, and then I differentiate the inside and multiply them together. So the differential of sine is cos, so it's cos of the function, and then I multiply by the differential of the inside. The differential of 3x minus 4 is 3. So I multiply by 3. And my answer is 3 cos 3x minus 4. Let's say I wanted to differentiate f of x being x squared cos of 7 minus 2x. Now this is more difficult because it's a product rule. You have the x squared and the cos 7 minus 2x. And it's the chain rule because you have the cos of 7 minus 2x. So let's use the product rule. We have u being x squared, and we have v being cos 7 minus 2x. If I differentiate x squared, I get 2x. And if I differentiate cos, I get negative sine. So I get minus sine of the brackets. And then I multiply by the differential of the inside, which is minus 2. Remember, with the product rule, you multiply these together. So I'll be left with 2x cos 7 minus 2x plus x squared times, you've got minus and a minus, makes a plus, so you've got 2 sine 7 minus 2x. So I want to simplify that down. I'll get 2x cos 7 minus 2x plus 2x squared sine of 7 minus 2x. And that would be how you differentiate that. Let's say we were going to use one with the quotient rule. Let's take tan of 3x plus 5 over the square root of x. And I want to differentiate this. Now remember, with the quotient rule, you can write this as the product rule as well. Or we just write it as u over v goes to u dashed v minus uv dashed over v squared. So in this case, u, which is the top, is tan of 3x plus 5. V is the bottom, which is square root x, or x to the power 1/2. If I differentiate tan, I get sec squared of 3x plus 5. And I times by the differential of the inside, so I times by 3. If I differentiate v, I bring the power down, and I take 1 off the power, I get minus 1/2. Now let's use the rule. So we have u dash v, so that's this one times this one. So I have 3x to the 1/2 sec squared, 3x plus 5, minus uv dash, that's this one, so minus 1/2 x to the minus 1/2 tan of 3x plus 5, and I divide by v squared. So I divide by x to the 1/2 squared. Let's clean this up slightly. So we'll leave it as 3x to the 1/2. You can write that as square root x if you want. Sec squared 3x plus 5. And then I've got minus 1/2. That's 1 over, so maybe actually we should write it like this. So we can write it as 1 over 2x to 1/2 tan 3x plus 5 over x. Now, at the moment, this doesn't look very nice, so I'm going to make this over a common denominator. The reason it doesn't look nice is you have this fraction here. So if I make all of this over a common denominator, if I multiply this function, top and bottom, by x to 1/2, what's going to happen is I get 3x sec squared 3x plus 5 minus 1/2 tan 3x plus 5, all divided by, now you've got the x and the x to 1/2, so that's x to the 3 over 2. And then maybe if you wanted to, you could times by 2 as well, top and bottom, so that get rid of that half, and that will make it a 6 and a 2. So that's how you differentiate the trig functions. Now let's look at the exponential and the logarithm functions. If I differentiate e to the x, I get e to the x. And this is one of the defining aspects of the exponential function, is that the gradient of the exponential function is the exponential function itself. That means that if I wanted to differentiate e to the 7 minus 4x, I do the chain rule again, so I do the inside and I do the outside. If I differentiate the outside, that's like e to the power something, so e to the power something stays the same, and then I just times by the differential of the inside, the 7 minus 4x, which is just minus 4. So the answer would be minus 4 e to the 7 minus 4x. And this is one of the general rules of differentiating exponentials, is that if I have e to the ax plus b, that leaves me a e to the ax plus b. If I differentiate a logarithm function, so let's say I want to differentiate ln x, I am left with 1 over x. If I differentiate ln of 5x plus 4, I do 1 over the 5x plus 4, because that's the chain rule again, so I'm differentiating the outside bit, which is the ln. I then differentiate the inside bit, so I times by 5. Let's do an example of that. So let's say, or for the general rule, sorry, let's say we're going to do ln of ax plus b. That will leave me a over ax plus b. Let's have an example of combining the exponential and logarithms together with one of our rules. So let's say I wanted to differentiate e to the 4x plus 3 times ln of 2x minus 7. Let's say we're going to differentiate that. Now I know this is the product rule because I have two things multiplied together, so we'll set out as normal. E to the 4x plus 3. V is ln 2x minus 7. Let's do our rules. So u dashed is 4e to the 4x plus 3. Remember, exponential stays the same. You just bring the differential down. V dashed is 1 over 2x minus 7 times by the differential, which is 2. So I get 2 over 2x minus 7. And remember, with the product rule, we do uv dashed plus u dashed v. So let's do that now. I'll do uv dash to start with, so I get e to the 4x plus 3 over 2x minus 7, and I add on u dash v. So 4e to the 4x plus 3 times ln 2x minus 7. And there we have it. That's how we differentiate trig, we differentiate exponentials, and how we differentiate logarithms.